This is Google Code Jam 2021 qualification round. It lasts for around 30 hours, but let's try to do it in 20 minutes, 30 minutes. That should be a good result. Okay, we sort an array by using reversing of an interval. Or actually, we always take minimum and we put it at the beginning. And it's very small. So we just run a brute force. If yes, then there is nothing to think about here. But I'm not sure if I got it correctly. Oh, yeah, I forgot that there are test cases and you need to print very particular thing. Case hash number. I will save it to another file to have it for other problems. I wonder if this problem is solvable if n is big, like, 1 million, because then you need to come up with a linear solution. Here it's like whatever. So we just run this pseudocode. Where is it? Here. For every from 1 to length -1, I believe for me, if I index from 0, it will be from 0. Oh, that's strange. Find minimum from now to the end. Okay, found the minimum, and now we reverse so that minimum would get here. And what's the cost? This. Okay, copy. 6112. Okay, good enough. Submit. Three minutes and a half, or 3:18, and we got the first problem. See the other one. Or actually they said that one problem is the same. Reversort Engineering. So maybe let's go with C, now that I remember. So this is completely passed, right? Cool. This should be a similar problem, and then I will get back to B. Find a list of indistinct integers such that the cost of applying reversort is exactly C. Alright, and n is up to 100. At least there will be a little bit of thinking here. So in C, it seems to be some kind of greedy algorithm. Like at the beginning, if I want to yield the cost of n, at least n, then I will put the minimum to the last position, and then I know that my first operation will be to reverse everything. If some other elements are initially this, then I will get, after reversing A, F, E, D, C, B, A. So I will kind of go from the end, maybe. Also, the cost is at least 1 from every position, even if I don't reverse anything. I need to take that into account. So do we do things in reverse or not? Like maybe I will first figure out this sequence with length n-1, and then I will decide where to put 1. No, didn't want to show that. So yeah, this problem will be for sure harder than the first one, but not too hard. This is C. We only get N or N and C input, N and C. We need to, the initial cost is at least n-1, I believe, if we need to reverse everything just like single element, because everything is already sorted, then it's exactly n-1. We don't touch the last element. And it's at most what? I think it's like n plus n-1, n-2, up to 2 for the last pair. So what's this sum? This is the sum of n elements, 1 through n, minus 1. Right. I will use this function. If not possible, I think we print minus 1. No, we print impossible. And now we go in reverse. Or do we? What about this? I will create a sequence with just values 0 through n. And then I will know how they move around. No, that's a bad idea. It's a bad idea. No. We go from the end. First we look at n-2, and either we decide to reverse that suffix or we don't. This is length of part to be reversed, and I say if I will be able to finish. So I consider from this position to reverse the part of this length. I wonder if the remaining things on the left are good enough. The remaining part on the left has length I. The total thing is n. I don't know if it matters. And the remaining cost will be this. Is this possible? So it will be now like n plus minus 1 and so on up to n minus prefix, I think. Or this plus 1. Something like that. Let's see an example. N is 10, prefix is 2. And what it will do? 2 times 20 minus 1. So 19. I think the total thing is 19, and this agrees. This is 10 plus 9. Alright. This is a good function. If this is still possible, then let's apply this operation. How do we do it? We need to say that maybe just reverse this part. This assert is that we get something here, and at the end we just print the answer. I'm really unsure. But I think we can use the previous solution to check this one. 4, 3, 2, 1. So can I just pass this in some way? What the first one got as the input? N. Okay, so let's try 3 test cases. In the first one we have n equal to 4, and I will just test this. N equal to 4, n equal to 2, and 7. Oh, this can't be right, because I'm reversing just everything. 6, 1, 12. Oh, actually this is right. Then what if I want here some other arbitrary value, like 20? So we use the first solution to the first problem as a kind of scorer to this other problem. No, A. 20, okay, it is fine. So that's everything. It's a bit scary to submit it like that, because I easily can have a mistake, like off by 1. But you know, if I want to have a good time, I need to take some risks. I spent 8 minutes on that. That might mean no first place. No leaderboard. I think something's wrong with their system, isn't it? I will start reading. Okay, we pay for occurrence of CJ and JC, and what? Okay, so when we want big blocks of just C's or just J's, whenever there are question marks, we will fill them with whatever is surrounding. And here it actually doesn't matter if we go with C's or J's. Does it ever matter what I do? Can I just always use the previous value? Yeah, I think so. Okay, C passed. So B, I think, is very easy, because I want long parts with same value, same character. I will just always copy the previous character. Do I print the string or the number? The number. N, limit for n, please. 1000. Oh, and we get XY as well. Can we ever get something wrong with the first character? I don't think so. Oh, X and Y, they can be negative. That's interesting. Then I don't want to minimize the cases like that. Okay, change of plans. I'm doing DP instead of greedy. All right. So dp of I, and there will be two possible states that best we maximize, right? Minimize. So smallest cost until ith position to put here like this 0 or 1, so C or J, this character here. Or just let's do it in constant space. And we minimize, right? Yeah, we do. So here, let's initialize as 0. And look at every next character. That. We don't need a big infinity, I hope. 1000, so it's fine. And now, if this character is either a question mark or C, then we can put here C. This is what? Either the previous one was also C, or it was J. And now we pay the difference from C to J. It's either X or Y, one of the two. I don't want to think which one. If I'm allowed to put here J, and I typed J instead of I, character J, then this, maybe I should swap X and Y. We'll see from tests. $583. No, that's wrong. What about first Y then X? Don't do it at home. You should just instead think which version is correct. Okay. What about the second test? -8. All right. $70 minutes done. Still 29 hours to go. Still no leaderboard. Why is it empty? Everyone, yeah, everyone. 2 problems left. Median sort. Sorting again. You can ask about median of 3 elements. The sorted order is either this or that. Oh, just an example. Okay, let's skip it. Order of T lists of n elements. So just sort n elements, I guess, by asking Q median questions. All right, they have interactive problems. So we want 170 queries per a test with 50 numbers, right? This one passed. We don't know if test 3 passed, the one with negative data, but I hope it's all right. I'm using infinity here. Length up to 1000, yeah, we should be fine. Time for thinking. How can I sort by using median? If I ask about first 3 elements and I get information that this is median, by asking about those, let's say that the first query I made is about those 3 characters. So the first query is called A. Then in the second query, I wonder, either I will ask about those 2 and the new one, or maybe maybe this one and new 2. Anyway, I want 170 queries instead of, right, for something of length 50. It suggests that it must be very fast, like faster than logarithm. N log n would be more than 170. By the way, regarding the leaderboard, is it just that they don't show leaderboard during the qualification round? That's bad. I would want to race with others. All right. We, of course, are going for the full score. Sort 50 elements with 170 queries. So not even divide and conquer needs to be faster. How can you sort faster than n log n? Or maybe just n log n with a very low constant factor. Let's see if we can apply divide and conquer. So kind of like in merge sort. If I sorted 2 parts, and now they are sorted here increasingly, I need to merge, then I guess it will be helpful to merge by taking a look at those 3 numbers. If this one is median, then I know order 1, 2, 3. If this one is median, then I know order 1, 2, 3. And if this one is median, then I know the order 1, 2, 3. So I will be able to sort those 3 numbers. So it seems that the such merge happens in how many? In, I think, n over 3. N over 3 queries. Because in one query I get rid of 3 numbers. Maybe even better, if then the second query will be about those 3, then no, something is wrong here. I don't decide about it. Let's see, if for example I have 1, 2, 3, oh, then I don't get rid of this number. I don't know how it is compared to this one. So I only can say that this one is first, this one is second. Okay, if this one is median, then those 2 are first. If this one is median, then oh, just this one is first. And I don't know if this is second, or maybe I need to take somebody from there. Oh, so that's bad. So it's like n over 1.5 or so, because sometimes I will be done with 1 number, sometimes with 2. Okay, so we have, I think, in total n log n divided by 1.5. I wonder what that value is. For 50, logarithm is around 6, right? $6,000? No, 6, not. Yes. 600. This is bad. If we divide it by 2, and I'm sure it's possible somewhere along the lines, then we're fine, but here this is not a way to go. Maybe thanks to the fact that we look at 3 numbers, we need some kind of ternary logarithm. Like maybe we need to merge 3 numbers, 3 lists at the same time. Then it will be here ternary logarithm. By the way, I think that this with binary logarithm is similar to n log of base 3 of n. Should be kind of the same, because 1.5 is close to logarithm of 3 with base 2. And this is what I think we would get by always splitting into 3 sub-arrays, then sorting each of them separately and then merging in n, which I think is possible. What else can we do? If we don't apply... But can we really do faster than n log n? It would mean that we can just sort numbers faster than n log n. Because we find maximum in one go, then we have maximum. Then asking median with that maximum is like comparing two elements. So that proves that we cannot do faster than n log n. I just need to improve the constant factor here. Are arrays guaranteed to be random? They don't need to random. I can random shuffle, and then I expect some proper order. One, two, three. This is best for us because we cut two numbers. But even if we always cut two numbers, then it will be here divided by 2, and that's still too much. It is barely lower than 300. Oh, this n is 50. Okay, so we already got 200, and it's just about improving it a little bit. Okay, that changes a lot. I used 150 instead of 50. Then I think I should implement this and just optimize it a little bit. By the way, can I do this? Okay, log of 3 divided by log of 2. 1.58. So what's n times log of base 3 of n? $178. This is n log of base 3 of n. This seems to be a way to go. We just need to get slightly below 170. But I think we will. Won't we? How do I distinguish maximum from minimum? Well, for big N maybe I can anyway. So yeah, if I split into 3 parts and I need to merge, then I will just compare those 3. Oh, and what then? I take median. So I don't know what to do now. Let's say that this is median. I can then, as the second query in blue, I can ask about those two and something very big. Maybe let's say I know that this is big. And then if I know that this is median, then I think that I know exactly the order that this is first smallest, then this is second smallest. There is some special case if everything here is similar to each other. But if what I wrote in blue is the case, then yeah, this is greater than that one. So it's 1, 2, or not really 1, 2, because then we continue here. Damn it. So in 2 queries, I got to know the smallest number. This is too much. It will fit, I believe, with some optimizations in 300. So maybe the binary thing. If this is median, then it's 1, 2. This is the best option. and I hope to often get it. But if this is the median, then it's even better, because it's 1, 2. Okay, so it's equally good, and then this one is bigger. The worst option is that this is the median. So then I only know that this is the smallest, but I know nothing else. And I want this case to be not very common. But I think just if I have uneven lists, then I will be fine. I wonder that maybe we shouldn't split evenly, like it shouldn't be 4 and 4, maybe 3, 5. If you have 50 elements, maybe it's good to split them in 20 versus 30, and then you will keep taking 2s out of 30 elements. And it will be rare that this is the case. I don't like this case. I don't like this when minimum is here. Whenever minimum is here, I'm good. Maybe even so, yeah, take like 20 elements here, 30 elements here, then we are more likely to have minimum there. That's one way to look at it. The other is always alternate. If I took minimum from the right, if smaller number was here on the right, then who's more likely to be the next minimum, this guy or that one? I think it's kind of the same. If you're the smallest, then I think it only depends on sizes. Or does it? I think only on sizes, all right. But with uneven here, we will more often get minimum. And here it will be rare. So maybe that will move us below 170. But right now our estimation is 200. Maybe I should think about small cases. So what if n is like 3? Can I deal with 3? Well, I can ask about them like that, and I will get information this is the median, but I cannot compare between smallest and biggest. Maybe I need to, in a very smart way, handle n equal to 4 or so. Let's say asking about those 3, I get median here. Yeah, I need to figure out a good way to handle small n. Maybe 4, maybe 5. Once I do it, then I will split like 50 maybe into just 5s. Maybe it would be nice to split 50 into 8 parts, because then I can nicely combine them. 50 is around 8 times 7, or what? Yeah, 6.5, 6 and a little bit. So sometimes I need to deal with n equal to 6, sometimes 7, and maybe by running brute force to figure out the best, I can try a lot of strategies to get one that on average behaves very well for small n. Or I can of course just say that this is around 16 times 3, but then I don't know how to sort a small sequence of size 3. Alright, we got our plan. It's time to start coding. Interactive runner. I think I prefer to implement it in my own environment first, where there will be a hidden array. I will be able to do more. It's nice that they provide Python runner. Oh, nope. I will handle that myself. And then we will be left with one more problem, cheating detection. But now, median sort. Let's go. But the format I can just take is from here. Which element is the median? Print ijk, all between 1 and n. Do I know n? I guess so. I can even say that n is global. Let's test with n equal to 10. And also there is some hidden array. Should I say that those are values from 0 to 10? Maybe. What do we do with in query? We look at those three indices, but they are from 1 to n. Of course, eventually I will need to print the query. Just flash the output, so it would for sure be really printed. And then to do is to, of course, read the response from the judge. But instead here, I will use my own environment for testing. I will take hidden of I-1, not this. I need to sort it in some way. For every index among them, let's say there is some, I will sort 3 pairs. I take value of u and the index, sort this, and among 3 sorted pairs, print the middle one. They are index 0, 1, 2, so let's print the one with index 1. And second is the index. First would be the value, and I don't care about the value. Yeah, I think this is good. No, I don't want this. I want struggle in my own operating system. Yeah, this is good. Let's, for starters, let's say what is hidden. And let's test this a little bit. I will read from the input the query, and I will print the response. Just for the sake of testing. Number of test cases. There is something hidden, alright, and now tell me the comparison between 1, 2, 3. The median is 1, that's right, but what about 1, 3, 4? Should be 3, okay, it's 3. And the 3 last elements, 8, 9, 10. Should be 9, it is 9. And 9, 10, 1. 9 again. 7, 8, 10 should be 7. Okay, it is 7. That's great. Let's implement the merge sort. Merge of 2 vectors that are already sorted. Those are vectors of indices. And I will keep asking about 2 elements from one of them and 1 from the other. I don't care much about the speed of my solution, so I can do things in quadratic time. The number of queries is very important. What if I will be left with 2 elements to check? Can that happen? It can. But I will need to take them with any previous element. That will be alright. So there is some total. Need to return it at the end. While the A is at least, I don't know, 2 elements. While both are at least 2 elements. At least 1. What do I do? While they are non-empty. And they have at least 3 elements in total. So one of them has at least 2 elements and the other has the third one. Let's take two elements out of the greater list. The longer one, I mean. Okay, so we take two elements out of A, like that. The median is this. And there are cases. If median is A of 0, then it means that B0 is the smallest. Else, if it's A1, it goes like this: smallest, second smallest. So we do this twice for A. Maybe I should have a function. Yeah, let's make a function. This is pop first, let's say. From it, either I get A or B. Let's make it just general. My code is quadratic because of this stuff, but I think it doesn't matter. It's fine to have quadratic complexity. No. Okay. So pop first of B, that was. Here twice pop first of A. The last possibility is that it's P of 0. That's the median. Then it must mean that A0 is the smallest and you are second smallest. So first A, then B. And now, it's possible that either they both have one last missing element, I need to do something with that, and I will achieve it by comparing with something that is already in total. I assume that at least one exists. So query of something smaller than them. And if that's A0, then A0 is smaller, otherwise B0. So it must be A0 or B0. Like that. And then I say that for sure one of them is empty. And now I can repeatedly just pop in any order. Like in merge sort, if you're left with some tail of one of the two vectors, one of the two lists, you just take it because those are the greatest elements. Let's see. And I will not read T, let's just say that T is 1. Return total. I don't even run it now, right? Oh yeah, because I need to initialize it in some way. Like for n equal to 4, I just need to come up with any plan. So let's first come up with plan here, but maybe later I will automatize it to find the best possible plan on average. Okay, we have 4 elements. We ask about the first 3 and we put here the median. And we get to know that the median is here. What then do we know? I can ask about either the things without median, or I can ask about 2 elements including the median and the third element. This seems annoying. I can also ask about every triple. There are 4 triples, and from this I will get something. Still, how do I distinguish between maximum and minimum? Maybe they oh, it is impossible to distinguish the order of any list from its reverse. Okay, so I don't care about minimum versus maximum. That's great. The order for each case is generated uniformly at random from all possible orders. That's cool too. So if I ask about every triple, I will get various medians, but only two of them will happen. If the real order is A, B, C, D, then only B and C can appear as the median. B will appear as the median twice, and C will appear as the median twice. So I think 3 queries are enough to handle n equal to 4. Any 3 queries. I will get 2 medians. I know that they are B and C in some order. And now for each of them, if B is the median, then on 2 sides I will get, oh, even better. In at least one query, B, C were both in the query. And I got some third element with them. Let's say that I got my thoughts are chaotic. So step 1 is ask any 3 queries. That is, queries about any 3 triples. Find all indices that occurred as medians, and they will be B and C. Find any query with both B and C. Say that B is median there. In this query, the third element of a query, element of this triple. So if B was median between C and something, the third element call A, and the fourth element is D. That's my plan. Thanks to asking 3 queries, for sure I will get something with both B and C. Maybe sometimes 2 queries are enough for that. So then I will improve it this way. But first let's go with 3 queries. Okay, let's now code this. So this is like, but don't we have a big issue that if every quadruple I sort and then I want to merge them, maybe I sorted one in increasing order and the other in decreasing order. Then I need to get them to the same style. Using some third element that I know is very small or very big, I can decide about this. But that's for later. So we have 4 elements. I need to ask 3 queries. I'm just following the plan from the right. Those are 3 out of 4 possible queries of a triple out of 4 elements. Also, let's make sure that here I'm indeed passing 4 elements. N will in fact not be divisible by 4. That's ugly for me, but I will handle it. I take all x, y, z and remove repetitions. I hope that now I have 2 of them and they will be B and C. Now find any query where I asked about both B and C. I need to save those queries maybe. So there is B and C in some order. Those are two elements of the set. Okay, I will again iterate over those possibilities. How can I say that? It will be a bit ugly, but it should work. If among those three there is B and there is C, let's make it better. Say there is some kind of R and T. I want to, in a better way, iterate over those. No. There is temporary set with A of 0 and A of R, A of T. This is exactly what I'm trying here. 1, 2, 1, 3, 2, 3. Those pairs, I iterate over them here. If TMP count of B and TMP count of C, then I have a case with both B and C. And I'm interested in the third value. So A must be for sure the last one. I can get it by summing up the 3 and subtracting the 2. This is the last one. Then D is the sum of everything minus the 3 that I found. And finally, I need to decide between B and C, and it depends on which of the three queries we have. B is the median, one of X, Y, Z. Here, I think I can take it like this. Create a temporary 3 elements array or vector like that, and access this element. So we need to say that this is B. Should be B. If should be is equals C swap. And finally we just say this. Please work, please work. I can check it, I guess, by saying for every I, this is just for testing purposes, for every interval of size 4, give me the merge between those 4 indices, not merge, the solve for. Like this. Something went wrong. In line 42, here it went wrong. So I'm passing 0 somewhere. That's because I deal here with indices from 0 to n minus 1. Did I already merge something? Median A of 0. So I want to deal with things from 0 to n minus 1, but let them have from 1 to n. Now please. We got something. I don't want to print queries for now because it's just confusing. This is the hidden sequence, and I got some order of the first 4 elements. I got order this guy, right? The one on position 1, then 0, then this and that. That's correct. cool. I'm very happy about this. Then 3214, that's 8730, that's correct. This order for those 4 elements, 38754. Yeah, it looks correct, just sometimes it's increasing, sometimes it's decreasing. But then we have merging. I need to figure out a way to merge 2 4s, for example, but in general 2 sequences, but one of them might be increasing and the other decreasing. So given the order A, B, C, D and E, F, G, H, sure, I can, like in merge sort, just keep comparing some here triples, but first I need to decide if they are both increasing or both decreasing. That's also fine. I don't want one of them to be increasing and the other to be decreasing. I'm thinking about maybe checking like AD and something from the other sequence. Hopefully the middle of this satisfies being between A and D. But theoretically everything here can be just between B, C, and then what? I don't like this problem. I don't know if I'm overcomplicating or this is just hard. I think I already passed because you need 30 points or so to pass. Actually, I don't know the exact amount, but you don't need to be in top, say 1000. You just need to score at least some amount of points. But I'm motivated to just get the full score. AD. Because if this is decreasing, I will keep thinking that A, B, C, they are smaller than E. Let's consider just arbitrary query between 3 numbers. And let's say that F is the median. Or maybe 2 neighbors. I think it will be good to ask about 2 neighbors, BC, and just arbitrary element in the other sequence. Say E. If E is between BC, then something. What if we get information that B is the median? Then what we want to happen is that when we ask about BCH, is that H is not smaller. We don't want to realize that they go in order B, E, C, but then H is actually smaller than B. So if C is the median between BCE, then it means that E is here to the right of C. I need to ask about H. Is there any other way? In every sequence in particular, I know minimum and maximum. I know A, D, E, H. What can I do about that? I can sort them. Yeah, we got it. We have a function to sort 4 elements, A, E, H, D. I can run this, and then I can check if in their total order, let's say this is fine, because A is before D and E is before H. But if the order was A, H, D, E, it wouldn't be fine. Because H goes before E and A before D. So I know that A goes before D, but then this one I need to reverse. So as the first step of merging two vectors, we need to grab the extrema, the minima and maxima, solve for A0, A back, B0, B back. And I need to know if they are in the same order. What's the easiest way to check it? For every vector out of the two, AB, go through the 4 elements. If in this order this element is A of 0, no, V of 0, and the other is V dot back, then we have, let's say, true that this is increasing order. Not else. And if the other way around, then decreasing. They claim that we always get a single pair, like in this quadruple. If we are looking for pair AD, we will get it once. Also, we once will get pair EH in some order. Oh, note here. Or for sure, order contains exactly 2 elements, and if they are not equal, I need to reverse one of the 2 vectors. So every merging first requires sorting a quadruple. What do you want? You want them in a vector. All right, now, where was my testing? Here. Let's solve for 0, 1, 2, 3. Solve for 4, 5, 6, 7, and then let's merge. This is theoretically the order of the first 8 elements. First we have 4, that's 0 indeed. 7, that's here. This is hard to read. I will create a function to say print values. Given some indices. This should be sorted. Perfect. Now let's try this like 10 times. Is every line sorted? It can be decreasingly, that's fine. I think it is. Great. What about number of queries? Every time when I ask a query, let's increase the number of operations. And at the end, let's print how many operations I did. 132, that's 13 per test for n equal to 10. That's not bad. But still we don't have the logarithmic part because I just have like this with force. Now instead I need to take split n into force. Perfectly I would want n to be 52, but yeah, we will deal with that. N is 50. Split at least 40a, let's say, into force. Then let's work with 20. 20 should be good. And split into force and then keep merging. There are some parts. Keep every next to I plus 1, not really that, solve for. And now keep sorting them. Well, there are at least two parts to merge. What you usually do in merge sort is you keep taking the two shortest ones. Two shortest ones. So let's just sort all the parts. Like this, and we take the first two. We will do merge of parts of 0, parts of 1. Let's go with the last two. Twice we erase the first element, so we in total erase the 2. Total is this. We have total and fingers crossed. Great. Okay, I need to use a toilet. Okay, whatever, I need to finish this problem. So with n around 50, we got that many queries with 10 tests. That's 50 per everything. So isn't that great? Oh, I have 20, right. Let's use 48. And we want to see here, what value do we want to see? 10 times, like 1700 is our limit. And let's test with t equal to 100. Now 17,000 is our limit. And we don't seem to cross the limit. That is great news. That is. Now then the only thing left is to handle n not being divisible by 4. I think what I need is I need to imagine that there are two more elements. Of course, one possibility for me. Wait a second. Can't I very easily deal with things of size 3? Because, oh yeah, 3 I can also sort. I'm stupid here. I can sort 3 just by asking once about median, and that's it. So I think that really it's better to here take triples. Huh. Yeah, I overcomplicated the problem. Let's just take triples, and then I sort it. I don't care if increasingly or decreasingly. So maybe this whole thing with solving force was unnecessary. What can you do? I'm putting median in the middle, then I'm asserting that middle is indeed the median, and returning A. I believe that this solves a triple, and now we can either take a quadruple or we can take a triple. So with 50, we will take one triple, two triples, 50, okay, maybe this. Do I need I? I don't. Well, n is not divisible by 4. Let's take a triple. And now, while n is greater than 4, we solve a quadruple. Nope, something went wrong. Maybe here. Oh yeah, I don't decrease. Oof, that was an easy fix. $204 parts of 0. So is it that parts is empty? Oh, it's very bad that I'm decreasing n. Let's remember n and then use it back. N is not 0, then what is it? Oh sure, while it's greater than 0. Now it should be. And I want it really for 50. I think we have a sorted sequence from 0 to 49. Of course, I will check it with asserts, but we exceeded allowed number of operations. That's bad. Let's see if this does better with triples rather than quadruples. Now I will have more parts and most of them are free. Okay, 17,600. So not really. If I had 52, what would that mean? Even more. For 48, we are good enough. For 47, which is not divisible by 4. Why did it? Oh, I didn't change. Okay, 47. Yeah, it's smaller. Just a little bit smaller n gives us better number of operations. And for 50, I'm just barely exceeding it. Then I think I need to here sometimes ask fewer operations, because maybe x and y are enough. Like here, if x and y already appeared, Will they be enough? Because later I'm searching for something with those two medians. Wait, so x is not y. They need to be different. I need exactly two medians. And they need to appear somewhere in those two. So let's start with just x is equal a of 0 and y is equal a of 1. That's of course possible. If that's the case, then I think we are done here. Because they exactly tell us that here a0 is the median, here a1 is the median, and I think that's enough. Because we can just go with the order a2, a0, and then a1, a3, I think. And that should improve the answer just a little bit. I think it went down by 300, so a similar if. If this, then it's the same, but the other way around. So why here this is the median. A of 3, a of 0, a of 1, a of 2. 17,100. Almost there, almost there. Generally, can I just do something in order to... Maybe I can make it more automatic. Say z is... Can I say just x? I will cheat a little bit. Only if medians that size is 1, then I will override. I also need z if the pair doesn't appear here as a pair, and that's only the case for a2, a3. So or medians is equal a2, a3. I think in those cases we need z, otherwise we don't. It doesn't exist yet. Here you go. Come on. Perfect. Just some asserts now to make sure that what I'm printing is indeed sorted, like here, to make sure that really I'm passing every test. But then it's just about reading the input and I'm ready to submit this. Oh, and I just from curiosity, if I do a lot of triples, oh, that's suspicious. No, or if I'm forcing a lot of triples, it worsened a little bit. Do I have 50? Yes, I have 50. So what was I going to do? Oh, make an assert. I have a function print something, print the values. Now for everything in values, if it's increasing, then increase the number of cases where it's increasing, otherwise decreasing. And I need to assert that one of them is 0. One of them didn't happen. Done. That's perfect. I can try with different seed just to make sure that I'm done. It still works. 16,100 something. No. Great. Whew. I spent a lot of time on this problem. It's now hour and 19 minutes into the contest. Still 29 hours left. That's more than enough. but I expected to finish everything in an hour. They give us interactive runner and testing tool. And what do I do? For example, okay, we have one of those. I will use this one on task D. Yeah. Wrong answer, of course. It can't open file testing tool. Okay, I see. Okay, expected something wrong. This is just because I'm not reading and printing properly. Now let's focus on input format, just because that before that I will copy D just in case if I mess up everything. And let's follow the format. Read T and Q. Read N and Q. I don't care really about Q, so I will ignore it. Hidden I don't longer need. Here I need to flash the output and read the response. Okay, print values shouldn't exist at all now, because in particular I don't have access to the hidden sequence. I don't know the values. And at the end, print a line containing n integers. And I believe that here I need to increase them by 1. Then there is the response. It needs to be 1, meaning that I got a correct answer. X is -1. Wrong number of tokens expected 3 or 10, got 5. So I print 5 without new line, it seems. Here print the new line. Let's investigate all printing. Maybe this is wrong. I shouldn't print case. Should I? I think I shouldn't. Assertion failed. Is it because for n equal to 10 I cannot split it into 3s and 4s? No, I can. So I communicate wrong with the judge. Yeah, plus -1, I see. Return x -1. Because they operate with 1 through n, I operate with 0 through n -1. Easy. Okay. Q is in this test 30,000, so we are good. Let's try now tests 1, 2, 3. Huh? Oh, because I guess this is 0, 1, 2. This 3 doesn't exist. Whew. Nice. Now, that being solved, we have A, B, C, D, and we have some leaderboard. I see that I'm not the fastest. I thought that there will be no leaderboard. So apparently I'm talking and drawing too much. Or also I'm just maybe too slow. Unless they didn't solve this for the full score, but I think I just struggled too much. I will be around here. Yeah, not the best position. Cheating detection. The last problem, E. Skill level and question difficulty are chosen in some range. Probability that he answers correctly is this. So depending on the difference between his skill and question difficulty. One player is a cheater. Flip a fair coin. If it comes up tails, they secretly look up the answer and answer the question correctly. Identify the cheater in at least P% of the test cases, and that is 86. What is in the input? 100 lines of 10,000 characters each. Okay, for every player there's something. I see. So for every question, wait, do I know anything about the uniformly at random? That's very good. If question is very hard, then almost everybody will fail, other than the cheater. The cheater will do well in half of very difficult questions. So let's find difficult questions, like top 1% or so, and let's print a person who gets the most correctly out of those. That's one possibility. But is he better than... Wait, what happens here? Half. If something is very good with skill 3, then here they answer half of very difficult questions correctly. But they will answer a lot of easy questions correctly. So I need to find somebody. No. Who is an outlier? Maybe find 1,000 most difficult questions, 1,000 easiest questions, and do something with that. Okay, the D passed, so now it's only E left. We can also do something with variance, correlation. I'm quite sure I will find 1,000 easiest questions and 1,000 hardest. I could also sort questions by difficulty, by sorting them by the number of people who solved them. Which actually, that's needed to do this kind of. So there are cases where the cheater is very smart and has skill around 3.0 and also can have skill around minus 3.0. The thing is that the frequency with which they answer easy questions should kind of match the frequency with which they answer hard questions. There is just some difference in that probability, and for them they will answer hard questions surprisingly well. So for every person, I think I get that. For every person, find somebody who has similar number of easy questions answered. So then I assume that for every person I found another person with similar skill, and then check if they also match regarding the hardest questions. Because I think there will be big discrepancy for the cheater. Okay, so for every person I will get two numbers, like, okay, I solved correctly 800 easy questions and 350 hard questions. And then if I'm this player and I see, oh, somebody else also answered correctly 799 easy questions, so that's very close to me, and answered correctly some number of hard questions. And if this is around 350, like maybe 348, then it's good. Like those are very similar. So this is similar, this is similar. But if this is, let's say, 320, oh, this is bad. It means that this guy cheated with hard questions. So for every person, I will find another person closest to me in terms of the first number, and I think I will look at this difference and I will print guy with the biggest difference. Now the question is whether I should use here 1000 or something else. That's the first question. The other is, do I want to make a local environment for testing? I think I want that, just to make sure that... Oh, visible verdict. That's great. So I don't need that. I will just risk a wrong submission this time. Can I download this big file? Okay, downloaded. So we have test cases, and for each of them, what is this, 0? I think for sample test P is 0. Is that the case? All right. For every person, we read his answers. Then I think I need to sort questions by difficulty. K is the number of questions and number of people. And difficulty for each of k questions. Difficulty of this question plus plus. Now we need to sort them. Questions. Difficulty and the index. Okay, and now we handle easy questions and hard questions. Easiest 1000 questions. Those are at the beginning of this. Questions of I dot second is the index. This is ID of a question. Now for every person, if for this person he answered this correctly, we say easy of this person plus plus. And hard questions will be done in the same manner after we reverse the order of solving questions. So now they are from most difficult. And yes, it's ugly, but I will copy paste here and I will just modify this to hard. Of course, it could be done with some for loop. What do you want? You want this. First, let's just print for a few people how many easy and hard questions they answered. Oh, this is bad. This is very bad. Easy and hard is the same, so I messed up. Not sort, reverse. And I again messed up because easy and hard are the other way around. So need to sort decreasingly. Like this. Cool. And now let's print it up to the 59th person because he's the one that cheated. We know that from the sample answer. 59. For me it will be 58. Let's see, 58. And we think that they cheated. Let's find person with similar thing. Yeah, easy. Big difference of heart. So close. Okay, sort them. And now for everything. Me is day of I of 2, that's my index. And there's my easy and the other easy. If I 0, then take I 1, otherwise 1, I minus 1. And how many I answered hard questions more than he did. $58, easy. Okay, I really need to go to that toilet, so let's hope for accepted. Oh, you didn't hear me for past few minutes. I was just saying now that I really need to go to that toilet. So I hope for accepted, and then, you know, contest is over for me. That's the last problem. I could still theoretically test a little bit. No, I need to make it better. Damn it. Right. So my solution is fine, like often it passes tests, but just not with accuracy of 86%. Top 20 is fine. I will try to get top 10. For this test, I guess I can print what's the second best guy. So my difference was 181, and now let's forbid considering guy number 59. For me it's 58. What's wrong? Oh, because this is the order, this strange order. If me is 58, then continue. Oh, the next guy is very close. I see. Do I need to really get some kind of correlation? Or like variance? No, so exact stuff where I need to look at every next question separately and see the outlier. Generally, we're talking about somebody who is lucky, who's just too lucky with hard questions. What about this? Instead of taking 1000, I can take 2000. And maybe that helps. It would be better to check this with a local testing environment. Oh, so here actually I'm messing this up if I move to 2000. What about 500 most difficult and 500 easiest questions? I again answered incorrectly. So it was, I think I'm passing like 30% of tests. Then I can also get weights for those questions. Like the hardest one will be most important, but then easier and easier. Here I need some formula. What do you want? Day of ice second. Oh, and this is double now. Okay. So we got it wrong again. For every person I'm computing his score with this heuristic. Now let's print it for a bunch of people. For 58 we got a big number, 140,000, but indeed for this guy we got something bigger. So it seems to us that he cheated more. I can also find somebody who answers. What about counting easy for all the questions? I think that's better. And just checking if they cheated on hard questions. Okay, so easy, it's just, everything. Easy plus equal 1. Find person who solved the most similar number of questions. And then for hard, let's go with n over 2, so with the top half of questions. Oh, numbers are too small. Yeah, but now we get a huge number for this single guy, but not for anybody else. I think now that now this is better. We can also improve it a little bit more by taking the average of two neighboring guys, maybe. Now I took average of two surrounding guys. 360 versus for others doesn't seem to be big. Should I maybe even do it for everybody, for all the questions? So just harder questions now, they have bigger score. I don't know what is better. So find a person with most similar number of answered questions and compare to your weighted score. Where for hard questions you get better score. I'm just worried that for smart people or for stupid people, this number will tend to be bigger. Like already here we see 580. I think the previous version was better, but maybe just because of our cheater, he has some smartness, some skill. So this here doesn't really matter. Oh, I messed up. So is it because of this? I don't know what did I mess up. So did it happen when I took all the questions? No. Oh, I think I changed this here. Wait a second, I'm doing something stupid. This should be K. This should also be K. Okay. I had a bug. I think so. So now for easy questions, so okay, for all questions I'm doing this, and now here for hard questions. I have huge value versus million something versus 170s. Now I can do it for, let's say, this. And I believe this might be better. I don't know. Let's submit this. But then if it doesn't work, I need to implement a local environment for testing. Just, to generate random tests and see what accuracy I have and experiment with values. Like, do I for just hard questions like top 10%, or for all questions I'm looking at something. Also show me this code. Okay, so here it was reasonable. I just look at top 10% of questions without any weights. But I can see why my current version is better. Easy, almost first try, and almost the win in the whole contest. 7th place. I had one incorrect submission, so for the next 4 minutes somebody can pass me. Okay, so small correction to what I told you earlier is that in this last problem, rather than looking at pairs of easy versus hard, I do this. For every person out of 1000, I count how many questions he got right. Let's say 350 out of 1000. Of course, I just look at this first number. Out of 10,000. Let's say he answered correctly 3,500 questions. And here there is some kind of strange score, a heuristic function. Okay, and then I find for him the closest, or actually two closest, and I take average of them, closest person in terms of solving problems, like how many problems they solve. Let's say there is somebody with 3430. That's the closest. And he also has some score. And what I'm computing in this score is weighted average. I say that every harder question, it has bigger score. Perfectly, I think the score should be this. If question is solved by, say, 30 people out of 30, then the score of this question should be 30. If it was solved by 100, maybe 70 or something like that. What I want to say, if question is hard, it should yield big score. And then your total score is the sum of points you got for all the questions. And the cheater, maybe even I should look at this. Cheater should get a big average of his score divided by this. So take the average difficulty of question you solved. But then it might be better just for smart people. So I think I got the right idea. To compare with somebody who has similar skill, and I judge it by looking at somebody with similar number of problems solved. And if really you're honest, then you will also have similar value of this one. And I don't take a look at absolute difference of those two, because those would seem to be a cheater. I just say how much this is bigger than this one. Because if I'm a cheater, I mainly cheat with hard questions and I get them right 50% of time. So more often I will solve harder questions. That's my solution here. Other than that, you were able to hear my thoughts during the contest. So if you have questions, post them in the comments below. Yeah, Kevin got 56 minutes. That's very nice. I spent, it seems, hour and 10 minutes on just median sort. Other than that, I spent 50 minutes in total. So I would have a good score, enough for top 3, if I solved median sort quickly. And I didn't, I would say, because I overcomplicated. I can also hope for moving one place up. If somebody above misses one of big tests, every question mark means you don't know the score, you don't know if you passed the test. So hopefully I will be 6th, maybe even if I'm lucky, top 5. That would be a nice achievement. Yeah, but top 3 was impossible because of me solving median sorts so slowly. 2 minutes passed, and for now nobody else solved one more problem. There is Dial, but apparently he also got some incorrect submission. Oh no, wait. +0 penalty attempts. So this one wasn't counted as incorrect attempt, just because I solved this test, I think. Like here it says +0 penalty attempts. Okay, then nobody can get better time. Yeah, if I had that incorrect attempt, then now Dial would be above me, I think. Right? Yeah, I think so. Cool. So I'm 7th place. If I mess up one of those two top problems, the question marks, then I will drop a lot. But if somebody above me messes it up, then I move up by 1 place, hopefully by 2 places. But if they run the scorer for median sort, then here it will pass. And this problem was just very easy. But you can just mess up maybe initializing something to 0 versus infinity. So that's some trap. Right. If you want to learn something useful before the next round of Code Jam, consider subscribing to the channel, because I'm going to post more short videos, lectures, tutorials on single topics. And consider following me on Twitch. Same nickname, Eric, though. I stream 3 times a week. Right. Thank you all for watching. Bye-bye.